Welcome to aminacademy.com. In discrete mathematics, let us discuss about properties of binary trees. The properties of binary trees are discussed below. Look at here. This is one example for binary tree. First, the maximum number of nodes at level L of a binary tree is 2 power L. Look at here. Here, level is the number of nodes on the path from the root to the node, including root and node. Level at root is 0. Look at, suppose your root is 0 you are keeping, then this can be proved by induction. That is, look at here, for root L equals 0, that number of nodes is 2 power 0, 1. Means here the number of node is 1. Here this is level 0. That is here the node is equal to number of nodes is 2 power 0 equal to 1. Assume that the maximum number of nodes on a level L is, suppose any level we can find number of nodes. Since the binary tree every node has at most 2 children, the next level would have twice the nodes, that is 2 into 2 power L. Suppose the second level, that node number of nodes is 2 into 2 power L, that is L can be any integer. The maximum number of nodes in a binary tree of 8h is 2 power h minus 1. Note here, the height of the tree is maximum number of nodes on the root to leaf path. The height of the tree with a single node considered as 1. Suppose single node, here height is 1, and that we can use here the height of the tree is the maximum number of nodes on the root to leaf. The height of the tree with a single node is considered as 1. This result can be derived from the point 2 above. A tree has maximum node if all levels have maximum nodes. So the maximum number of nodes in a binary tree of 8h is 1 plus 2 plus 4 plus 2 power h minus 1. It is simple geometric series with h terms, and the sum of the series is 2 power h minus 1. In here, next one, the binary tree with n nodes, the minimum possible height or the minimum number of level is log n plus 1 base 2. This is a minimum number of levels formula. Each level should have at least one element. So the height cannot be more than n. A binary tree of 8h can have a maximum of 2 power h minus 1 nodes. So the number of nodes will be less than or equal to maximum value. Suppose if you apply h value, we can get nodes. Number of nodes is 2 power h minus 1. Look at here, n is lesser or equal to 2 power h minus 1. That is 2 power h is greater or equal to n, that minus 1 go there side is n plus 1. Now taking log both side, log 2h base 2 equal to log n plus 1 base 2. Then this 2 come to the power, that is h log 2 power 2 q's, that is h log 2 base 2 is equal to log base 2 n plus 1. H is an integer, therefore h is greater or equal to modulus of log n plus 1 base 2. So the minimum height possible is modulus log n plus 1 base 2. In any tree, the minimum height possible is this here. Binary tree with L leaves has at least log L base 2 modulus plus 1 levels. A binary tree has the maximum number of leaves and a minimum number of levels. When all levels are fully filled, then let all leaves be at level L. Then below is valid for the number of leaves L. Therefore, you can say L is lesser or equal to 2 power L minus 1. Therefore, L is modulus of log L base 2. Modulus of log L base 2 plus 1, where L is the minimum number of leaves. In a binary trees where every node has 0 or 2 children, we know that the number of leaf nodes is always one more than the nodes with 2 children. Therefore, L equal T plus 1, where L is number of leaves nodes, T equal number of internal nodes with 2 children. We can prove it by, look at here, that is here, number of leaves nodes L, that is total element present at the bottom of tree equal to 2 power h power minus 1. H is the height of tree. Number of internal nodes equal to total number of nodes minus number of leaves, which is equal to power h minus 1 minus now finally we will arrive L equal to 2 power h minus 1, therefore T equal to 2 power h minus 1 therefore L equal to T plus 1, hence proof. That is L equal to number of leaves equal to total number of that is T plus 1, where T is the number of internal nodes. In a non-empty binary trees, that properties we discuss here, in a non-empty binary trees, if n is the total number of the nodes and e is the total number of edges, then e equal to n minus 1. Here, where e is the total number of edges, which is equal to number of nodes minus 1. Every node is a binary tree, has exactly one parent with the exemption of the root node. So if n is the total number of nodes, then n minus 1 is the nodes have exactly one parent. There is only one edge between any child and its parents, so that the total number of edge equal to n minus 1. Now we'll discuss further some extra properties of binary trees are. Each node in a binary tree can have at most 2 child nodes. That means one node have at least at most 2 child nodes, left and right. In a binary tree, each node can have either 0, 1 or 2 child nodes. That means here, look at here, this like or or 1, 0 or 1 or 2 nodes. If a node has one child, it is called a unary node. If a node has two children, it is called a binary node. The node at the top of the tree is called the root node. The root node is the first node in a binary tree, and all other nodes are connected to it. All other nodes in the trees are either child nodes or descendant nodes of the root node. Node that do not have any child nodes are called leaf nodes. In last line, there are leaf nodes. Leaf nodes are the endpoints of the tree and have no children. They represent the final result of the tree. The height of the binary tree is defined as the number of edges from the root node to the deepest leaf node. The height is of the binary tree is defined as the number of edges from the root node to the deepest node. The height of the binary tree is the length of the longest path from the root node to any of the leaf nodes. The height of a binary tree is also known as its depth. In a fully binary tree, every node except the leaves has exactly two children. In a fully binary tree, all non-leaf nodes have exactly two children. Non-leaf nodes have exactly two children. This means that there are no unary nodes in a fully binary tree. There is no unary nodes in a fully binary tree. That means all are binary nodes only. In a complete binary trees, every level of the tree is completely filled except for the last level, which can be partially filled. In a complete binary tree, all levels of the tree except the last level are completely filled. This means that there are no gaps in the trees and all nodes are connected to their parent nodes. In a balanced binary tree, the height of the left and right subtrees of every node differ by at most one. The in-order, pre-order, and post-order traversal of binary trees are three common ways to traverse the tree. That means in-order, or pre-order, and post-order are three different ways of traversing a binary tree. In order traversal visits the left subtree, the node itself, and then the right subtree. Pre-order traversal visits the node itself, the left subtree, and then the right subtree. Post-order traversal visits the left subtree, the right subtree, and then the node itself. We'll discuss in future videos about this type of order. We know a tree is non-linear data. Tree has a non-linear data, which means it has no limitation on the number of children. A binary tree has a limitation as any node of the tree has at most two children, left or right child. Now we'll discuss about complete binary tree. A complete binary tree is a special type of binary tree where all the levels of the tree are filled completely except the lowest level nodes, which are filled from as left as possible. Here, this level is completely filled, but this level is not completely filled. This is the outermost level. That means before the outermost all levels are completely filled is called a complete binary tree. Some terminology of complete binary tree. Root. Node in which no edge is coming from the parent. Example, node A. Here, node A is root from node having some, that means what? Node A is a root node. Node in which no edge is coming from the parent. Second, child. Node have some incoming edge is called child. Example, nodes B, F are the child of A and C. B and F are child of A and C respectively. That means node have some incoming edge is called a child node. Node B and F are the B is a child of A, F is the child of C. Siblings. Nodes have the same parents or siblings. Here, these are B and C are siblings, means brotherhoods or sisterhood. These are siblings of sibling nodes. This sibling of same parents of A. B and C are sibling of parent A. Degree of node, the number of children of a particular parent. Example, degree of A is 2. Degree of parent A is 2 children, 2. And degree of C is 1 because only one child. Now, internal, external nodes. Leaf nodes are external nodes and non-leaf nodes are internal nodes. Here, these are the leaf nodes, that is D, E, F are leaf nodes. These are external nodes, and here B and C are internal nodes. Level. Count nodes in a path to reach the destination node. For example, level of node D is 2 as 2. Level of D is 2 node. Level of node D is 2 as nodes A and E from the path. A and D, that is level of node D is 2 as nodes A and E from the path. Height, number of edges to reach the destination nodes. Roof is at a height 0. Example, height of the node E is 2. That is, height of the node is 2 because from here one height, from that one is another height. That is, it has E is node, height of the node E is 2 as it has 2 edges from the root. Property of complete binary tree. A complete binary tree is said to be a proper binary tree where all leaves have the same path depth. In a complete binary tree, number of nodes at depth D is 2D. In a complete binary tree with n nodes, height of the tree is log of n plus 1. All the levels except the last level are completely full. A perfect binary tree is a special type of binary tree in which all the leaf nodes are at the same depth. These are all the leaves are same depth, that is 4, 5, 6, 7 are having same depth. It's a perfect tree, and all non-leaf nodes have 2 children. This have all non, that is this is non-leaf nodes have 2 children. In simple term, this means that all the leaf nodes are the maximum depth of the tree and the tree is completely filled with no gaps. Perfect binary trees and completely binary trees, both we'll discuss here. A binary tree of height h having the maximum number of nodes is a perfect binary tree. Look at here, a binary tree of height h having maximum number of nodes is perfect binary tree. For a given height h, the maximum number of nodes is 2 power h plus 1 minus 1. A complete binary tree of height h is proper binary tree of up to height h minus 1. Up to h minus, this is up to h minus 1, it have, that is a complete binary tree of the height h is a proper binary tree up to height h minus 1, and in the last level elements are stored in left to right order. So far we discussed about detailing and properties of binary trees. We have done. Please subscribe our YouTube channel.